Hi guys, one last video to help you get ready for your Module 18 test. We've learned a lot about equations in Module 18, all right? But one thing you got to know is some equations sometimes will not have any solution at all. We usually get one answer when we're done, all right? You're going to run into some problems that don't have an answer at all, okay? And that's called no solution, okay? And this is an example of what it'll look like when you run into a problem or an equation that has no solution. What you're going to see is the same variable on the left and right side of the equation, all right? And you're going to see different constants, making it impossible for the left side and right side ever to be equal, all right? So if we think about that, whatever number n is, it has to be the same number here since n is the same number as n, right? So if I put a 5 in here, that has to be a 5. If I put a 10 in here, that has to be a 10. If I put a 1 million in here, that number has to be 1 million. So if I pick a number, any number I want, I'm just going to pick a random number. I'm going to ask my wife right now to pick a number. Honey, what's a number I could pick?
8.
All right, I'm going to pick the number 8. If I put it in there and there, do we think the left and right side will come out equal? No, it's impossible, even though this is 16 and this is 16. Are the left and right side going to come out equal? No, because I have a plus 4 here and a plus 3 here. So this side would come out to be 20, and this side would come out to be 19. So no matter what number I put in here, even if I picked a negative number, all right, this side's always going to come out to be 1 bigger than this side, no matter what this number is here. All right, just to prove it, I'll change that to a negative 8 and a negative 8. All right, so that would be negative 16. Okay, that's no longer going to be 20, right? Negative 16 plus 4 is negative 12. Negative 16 plus 3 is negative 13. And look at that, this came out to be 1 bigger than that again. It always will, no matter what number you put in there, all right? So these, since the left side and the right side can never be equal, we say there is no solution, all right? And this is a symbol you can use also sometimes, you'll see, all right? Okay, it's not always as straightforward as the one we just looked at. Sometimes you're gonna have to do some work, and then later on you'll find out there is no solution here, all right? All right, so if I look at this equation here, there's no parentheses, so I don't have to worry about the distributive property. So we can go into kind of combining our like terms here, all right? So I have a variable, a constant, and a variable, and they're on the same side, so I can already combine these two together here. What would that give me if I combine those? 10w minus 6w, that would be 4w, okay? And then my minus 8, I'm just going to bring it down, okay? On this side, I have a variable, same variable, and a constant, so I can combine these two just like I did over here, 3w, and we know that's really 1w. What would that add up to? That is 4w, okay? And then I have a minus 10, all right? So again, we see just like we did in the previous example, I have the same variable, 4w and 4w on opposite sides. And since these two numbers are different, we're going to say there is no solution because these pretty much cancel each other out, right? If we subtract 4w from both sides, and these will never be equal to each other. So therefore, we can say there is no solution. Or again, you can use that symbol for the null set, okay? Okay. Here's one more case. Sometimes equations may have infinitely many solutions. That means no matter what number we plug in for h, you're going to get the same value on both sides here. Okay, so that means, remember, this is h and this is h. These got to be the same number here. So I'm going to ask my wife again to pick another number here. Let's see if the left side and right side, and she's just picking a random number. Go ahead.
4.
If I plug in 4 here and 4 here, what am I going to get here? So 24 minus 10 is 14. 24 minus 10 is 14. No matter what number we put here, if I would have put negative 4 here and negative 4 here, I would have got the same value here at the end. Okay? So the key is to see that the variables are the same and the constants are also the same. Pretty much the left and the right side are exactly the same, so no matter what number we use for h, you're going to get the same value on both sides. That means that any number is a solution. That's called infinite solutions, okay? So again, could be hidden sometimes here. So here's one more example to look at together here, okay? All right, so right now it looks like there's a lot of different stuff here, so you wouldn't expect there to be infinitely many solutions, but sometimes it's hidden here. All right, so we got to do some work. All right, so we see the parentheses, so obviously we do our distributive property first here. I have 2 of those, and I have 2 of those. All right, so 2 times 4t is 8t. 2 times plus 6 is plus 12. Okay, on this side there's no parentheses, so I can just combine my like terms if I want here. I have a negative 2t and a positive 10t. Those are both variable terms. If I add them together, there's 8t. 10 minus 2. And I could do the same here with my constants. A positive 10 and a positive 2 is obviously plus 12. All right, and if you look now, exactly the same on the left and the right. That tells me these cancel, and no matter what, these will always be equal. So we say there are infinitely many solutions, and that means no matter what you plug in for t, the left and right side will be equal. Okay, I hope that was helpful.